Good evening, my dear J Warriors. This is your Captain Shreyas, and we are on to yet another amazing class of your Class 11 syllabus. So it's not just for 2027, huh? It's for 2026 students also because you guys would have forgotten. Maybe you're a dropper student. So let's do it, guys. And we are on to non-uniform motion of one-dimensional motion, okay, and graphical aspects. So calculus, derivatives, integration, applications you're going to see, and also you're going to see some graph-based graph conversions, areas and slope-based questions, etc. By the way, the prior requirement to watch this class is you have to know at least basics of derivatives and basics of integration. If you have not yet studied it, don't worry, it's there on the channel. You can definitely check it out. The link, I mean, go to the live part and go behind a little bit. If you can't, if you're lazy enough, no issues, go to the home tab and just go through this particular class 11th or 2027 preparation in this particular playlist. You are definitely going to find it over here. Okay, areas and integration, slopes and derivatives, and even the basics. So if you have missed any of the classes, please watch it. Okay, cool, guys. And let me also remind you that as you're watching this video, a lot of students might not know today is the final day of joining the Sigma batch, and a fresh entry point is starting 21st. So if you have not yet been a part of the Sigma batch, please check out the link which is there in the description box over here. This is for 2026 aspirants. It's a very affordable batch in pure English where you will find my content along with our J English teachers and our pro batch and offline pro teachers. It's just for 5,000 below only, and with the Tattva books and the QR codes, it's barely 9,999. Okay, so you're getting the hard copy books and revision material also delivered at your doorstep along with test series, study assignments, class tests, revision modules. Everything is a part of this. Okay, so please do check it out. But if, sir, I want to join for 2 years, then you have multiple options, either offline, okay, or you can also check our pro batches online. Okay, so do check out. The links are there again in the description box. In fact, I would suggest go book a free demo. That way, your chances of getting discounts, maybe you have some achievement which you can share, will be considered in granting you some scholarships. So please fill up this form in case you are a 11th student, or maybe you are taking a drop and you want a full-fledged personal mentorship. Okay, so this is your Captain Shreyas. Let's begin with the class. Hi, Khushwat. Welcome, everyone. Yeah, I hope I'm audible, visible to all of you. Okay, and I hope you have smashed that like button. In case you have forgotten, please do that. Okay, I need to keep reminding you. Okay, sir, why your batch is only for class 12th and dropper, not for 11th? Himikti, the thing is, see, maybe we don't have so much bandwidth right now. My batch, I wish maybe I will next year make it for 11th standard students also. The thing is, most of the students who know me right now, we did an analysis, were 11th moving 12th students, so and dropper students. But maybe next year, if we have more 10th moving 11th students, then maybe we could have done that. Yeah, that is the thing, because we also need to have some bare minimum students in the batch. If it is just 50, 100 students, then it doesn't make sense. We need couple of students at least to run the batch smoothly. Okay, correct. Okay, but no issues, Victor. You can still join the batch, and the batch is still there for good 8 to 10 months now, because it is going to go on till JEE Advance. Yeah, so if you're looking at it that way, if you want something like that, then I think it's still a good time. Okay, and don't think about the months or the weeks lost. Think about the months which you have left, and think, what if you are not part of this? Then if you join a crash, so many months of preparation you will miss, right? Hi Tharuna, hi Vijit, just joining on time. Cool. So let's begin. Okay, I want you to be very, very, uh, I would say, motivated, guys, because this year we had amazing results. It's become very tricky now, because if you have to, you know, I would say, beat them. If you want to do more than what your seniors have done, you have a lot of task ahead of you, because students have done extremely well, guys, like getting 128 of 120 in maths in J Advance, or getting all India rank 15, cracking the CET entrance exams or even getting all India rank 1 in ISI exam, the benchmark is very high. So better get going. If your seniors have done this much, you need to do more than this. Okay, you cannot just be all India rank 1, 3, 6, and 10. I want even the fill in the blanks 2, 4, 7, 8, 9, everything. You should be here. Okay, so a lot of responsibilities there. So better buckle up. So quick revision of what we had done in derivatives, differentiation, or basically derivatives, or basically rate of change, rate of change. So if you remember, we have already mentioned that if you have some function like this, y is f of x, that function could be like this. Maybe this is your y-axis, maybe this is your x-axis, maybe this is your function like that. It changes. Then the derivative of that function, is written down like this, dy by dx, or you can use the symbol, or you can also use the symbol f dash of x, and that is equal to nothing but the slope of the tangent drawn, to the curve, which is also equal to tan of theta. So if you want to measure what is the derivative at this particular point, example, you draw a tangent at that point. That particular point. As you can see, this is the tangent, and you measure the slope of it. And the slope is nothing but, if you measure this theta, tan of theta will give me the slope of it. That is what derivative was. And then we have seen common derivatives of many functions, like for example, derivative of x raised to n with respect to x is nx raised to n minus 1. Then derivative of a constant with respect to x is 0. Then we have also seen derivative of e raised to x with respect to x is just e raised to x. Derivative of log of x is 1 by x. All these things we have seen, correct? Even trigonometric derivatives. So derivative of sine of x is nothing but cos of x. Derivative of cos of x is nothing but negative sine of x. All these formulas we have seen. What is the slope of every function in our previous discussions? Cool. Remember it, guys? Yeah. Okay. All right. So any such doubt of any book, please put it up in the comment section. Abhijit, I will definitely have a look at it, or you can probably get in touch with me on Telegram like that. But Telegram, very difficult for me to answer every question. So better put it up as a comment. Maybe not just me, other students also keep checking our comments. So, they will definitely pounce on that comment and try to help you. Okay, cool. Now, if you remember integration was also used for calculating areas. So again, if you have a graph of y versus x, this is y, this is x, maybe this is some function over here. So if you have some function over here, then the integration of that particular function, so integration of y with respect to dx, or you can also call it as integration of f of x dx, is nothing but the antiderivative. It is the antiderivative, if you remember, antiderivative plus a constant of integration. This type of integration, when you perform, it was called indefinite integration. This antiderivative means whose derivative is this. So if this is sine of x, integration of sine of x means whose derivative is sine of x. It was basically negative cos x, like that. So if you put limits over here, like for example like this, x1 to x2 y dx, y dx, then that will always give me area under the graph, area under the graph. Like say example like this, maybe this is some value to this some value. So this particular area, this particular area is what I'll get if I integrate it with limits. And remember, that was called as definite integration. That was called as definite integration. Yeah, everybody remembers this? Perfect. Just a quick recollection of the formulas, my dear warriors. Integration of dx was x, but plus constant of integration, because I have not put limits. Integration of x raised to n is nothing but x raised to n plus 1 by n plus 1 plus constant. Integration of 1 by x is nothing but log of x, again constant of integration. Integration of e raised to x is just e raised to x only. Integration of cos of x is nothing but sine of x, and integration of sine of x is negative cos of x. All these things we have seen in the basics of mathematics class. Just a quick recollection. There are many more formulas, but I'm giving you the usual formulas which you will be encountering in most of the physics part. Yeah. Hi Ansika, welcome aboard. And Taru, I got low marks in physics. What should I do to improve? I made mistakes in theory part. Tarun, I would suggest please watch my classes. A to Z, everything playlist is there. Plus, if you're in any of the batches, Pro or Prime, you will find my entire repository of detailed classes of JEE Mains and Advanced, taught entire syllabus properly in front of you. You will feel like as if I'm sitting in front of you and teaching. Please watch the classes. I explain theory beautifully. Obviously, problem solving also I do, but if you find, sir, theory only I didn't understand, see how I use the theory, see how I apply in the formulas and questions. That's how you will build it. And don't watch 50-minute, 1 hour classes. Watch detailed classes. One shots, not the time. Watch proper detailed classes. Okay, and yeah, per day at least 3 to 4 hours. If you study, that will be good enough. Okay, Abhijit. Great. So that was the basic recollection of derivatives and integration. So now let's see how do we use it in our other questions. First, let's talk about displacement, then velocity, then acceleration. If you remember, velocity was rate of change of position. Our average velocity was a large change or a decent change in the position upon the time interval. This was average. So what will be instantaneous velocity? It will be a very small change in the position in a very small change in time. This will be instantaneous. This will be instantaneous velocity at that point. So this is nothing but the rate of change of position. That is your velocity. And if you think carefully, if I have a graph of displacement or position, let's say R or S is displacement or R is position versus time, and that graph could be anything, literally, something like that. If somebody draws a tangent to the curve and they measure what angle does the tangent make, then the slope of position versus time, that is what will give you velocity. The slope, how steep it is. If the position is changing fast, zoop, it will be here. Fast it is changing, so velocity is higher. If it is not changing, then the graph will be like this. I mean, horizontal. So at this point, you can see the graph slope is horizontal. That means it is 0. So at that instant, your velocity is 0. Okay. So that is what the graphical meaning will be of instantaneous velocity. So let me just obviously block this. So slope of position time is velocity, and so is this. Same logic if I apply in the reverse. Same logic if I apply in the reverse. Integration of velocity with respect to time, integration of velocity with respect to time should give me position, but without the limits, I will have constant of integration. Because think logically, if velocity is the derivative of position, position will be integration of velocity. So it could be x, y, z, or I can just say r also. R is some position. If I put it with limits, integral v dt from t1 to t2, then it will be nothing but r2 minus r1, position at 2 minus position at 1, which is then displacement, which is then displacement, because the displacement is nothing but your change in position, change in position. So when you do definite integration, you will get displacement. When you do indefinite integration, you will always have some ambiguity. You will again have to use some other equation or method to find that C, but it will give you then the position of that particular particle. So because definite integration is also area under the graph, which also means that if you have a graph of velocity versus time, okay, velocity versus time, maybe it is something like this, and you figure out the area between 2 points like this. You figure out the area between 2 points from t1 to t2. This area that you see over here, this area that you see over here, area under velocity versus time, that is going to give you this value, which is displacement, which is going to give you nothing but displacement. So area under velocity time is displacement. Also, I can block any of these formulas, okay, which is very, very important. Clear, guys? Give me a thumbs up quickly. Okay, everyone with me on this? Okay, so position, derivative, velocity, velocity, integration, position, because integration is anti-derivative, anti-derivative. Okay, sir, fair enough. Sir, then shall we do acceleration also? Why not? Say, average acceleration was a big change in velocity. This was average velocity upon, sorry, average acceleration, which is big change in velocity upon a decent time interval. So if I want instantaneous, the delta will become d, small change of velocity in a small time, that will be instantaneous acceleration. This is nothing but rate of change, rate of change of velocity, rate of how quickly the velocity changes, the rate of it is acceleration. Graphically, if I have to say it, I have to look at the graph of, you only think whose graph I'll have to look at, rate of change of velocity with time. So velocity here and time here, and I will just draw chumma some graph, okay, of velocity with time. And if I draw a tangent at any location, it doesn't matter, here, 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 there. So some tangent I draw and I measure that particular angle over here. I draw that tangent. So the slope of velocity versus time, that is what will give me acceleration. Slope of velocity versus time will give me acceleration. So instantaneous acceleration is the rate of change of velocity or the slope of velocity versus time. Pretty straightforward. Obviously, we can go to now the exact opposite of it. If acceleration is derivative of velocity, velocity will be integration of acceleration. So I can say velocity will be integration of acceleration. So if I integrate acceleration with respect to time, I'll get velocity, but no limits. So plus some constant, but usually we'll have some limits, say from t1 to t2. So if I integrate it with limits, I will get v2 minus v1. Velocity at 2 minus velocity at 1, which is nothing but change in velocity. There is no name for it. It is just change of velocity. Nothing more, nothing less. Okay, change of velocity, of course. Change of velocity. So again, graphically, if you want to see, you don't have to by heart any graphs, guys. It is like if you know what integration is, you automatically know who versus who graph you need to draw. Integration of acceleration with time. So graph of acceleration and time. So it could be any random graph, and you take two random points, maybe here to maybe here. This is T1, this is T2. You try to find the area under this. You try to find the area under this. So area under acceleration versus time, that never gives you velocity, it always gives you change in velocity. So lot of students make this mistake. I've seen it in almost every exam. They think it is velocity. Wrong, it is change in the velocity. So these are the four main things which you will need throughout the chapter. Position to velocity derivative, a position to time, position with respect to time derivative, you will get velocity. If you take the derivative of velocity again, you will get acceleration. Same way, if you integrate acceleration, you will get velocities change. If you integrate acceleration, you will get change of velocity. And if you integrate velocity, you will get change in position. That's how it goes. Okay. That's the most of the things that you will need throughout the chapter. So maybe we can do some questions on this just so that you get an idea. Say for example, the position of a particle is t cube minus 2t. Can you quickly find the velocity and acceleration? Also find velocity at 2 seconds and acceleration at 2 seconds. Okay, can we quickly do this question? I think we can easily do it. See, if you want to find velocity from position, we need to do derivatives. So velocity will be derivative, that means dx by dt. So derivative of this guy, which is t cube minus 2t. So think logically, derivative of t cube, use x raised to n formula, n will come outside and power of n will reduce by 1. So 3 will become 2 minus 2, derivative of t is just 1. So it is just 3t square minus 2. So therefore, how much will be velocity at 2 seconds? So put the value of time as 2. So this will become 3 multiplied by 4 minus 2. 3 4s are 12. 12 minus 2 is 10. So it will be 10 meters per second. That is the instantaneous velocity at 2 seconds. This is instantaneous velocity at 2 seconds. That is the meaning of it. Let's go ahead. We have to also find acceleration. So acceleration is derivative of velocity. So acceleration being derivative of velocity, again you have to take the derivative whose derivative you have taken. So this is what it is. So it will be the derivative of velocity, which is 3t square minus 2. Okay. So what is it? 3 is there as it is. T square's derivative is 2t raised to 1 minus 2 being a constant, derivative is 0. So acceleration is 6t in general. So now we need to figure out what is the acceleration at 2 seconds. So 6 multiplied by 2, 6 2s are 12. So 12 meters per second square is the answer at 2 seconds. Okay. No, this is not the first lecture. This is the last lecture of 1D kinematics. The previous lectures are there in the live section. Just go to the live section and just go through the previous ones. You will definitely find it. Okay. And hi sir, I'm in ISC board currently. Do you think I should focus on NCERT or ISC syllabus for JEE? You are in 11th or 12th, Bhavbot? Please tell me that, because that depends. Okay. All right. Now let's do another question coming up on your screen, guys. Here it comes. Here it comes. Let's say the reverse has to be done. Let's say acceleration is maybe t square meters per second square. Velocity initially is 2 meters per second and position initially is 1 meter. Question is find velocity and position in general. Question is find velocity and position in general. So this is exact reverse, guys, if you think about it. From position finding velocity and from velocity finding acceleration, it's the question about derivatives and slope. Going reverse, from acceleration to velocity, velocity to position, it is integration. Okay. So whenever rate comes, it is derivative. Whenever area comes, it is integration. So acceleration is given. I think the first job is to find velocity. And what is the logic behind it? Remember, integration of acceleration with respect to time is nothing but change in velocity if you put t1 and t2 over here. Usually do it with upper and lower limits. What are the limits over here? If you notice, it is clearly mentioned v0 is 2. That means when time is 0, initially already the velocity is 2 meters per second and the acceleration is just t square. So this dt is there. So it will be velocity initially, that means 0 seconds. 0 seconds, how much is it? It is basically 2. And at t seconds, how much is it? I do not know. See if you understood what I just did over here. This is upper limit. That means when the time was t, then the final velocity is v. When the time was 0, then the velocity initially was 2. Why? Because it is given. This is one of the most crucial steps. Take a moment, take 20-30 seconds. Yeah. Okay. I hope this is absolutely clear. Okay. Yeah. No, for last question, everything is fine. Nothing is cancelling. Okay. Moving on. What do we do? Integration of t square. Come on, guys. It will be t raised to 3 divided by 3. And we have to put those brackets because limits are still existing. And this will be nothing but v minus 2. Okay. So first put t, so t cube by 3, then put 0, so 0 cube by 3 is equal to v minus 2. So v will be just t cube by 3 plus 2 meters per second. So we have found out velocity in general. Take that minus 2 over there, this is 0, so plus 2 and t cube by 3. So first part is done, finding velocity is done. How do I do the next part? Position. Okay, position. From velocity, if you integrate it, you will get position. So integration of velocity with respect to time from t1 to t2, that will give me the change in position, which is displacement. Very similar logic I have to use here. Velocity already known to me. It is nothing but t cube by 3 dt is there plus 2 dt is there. Lower limit t1, when time is 0, position is 1. So initial position is 1. When the value of time becomes some random t, then the position is x. That's how the limits go. Final minus initial. Final time, initial time. Final position, initial position. Initial position given to me. So 0 is to 1, t is to x. I do not know x. Time is some random value. You put time, you will get x. Like that it is. So integrate it. So what will this become? Come on, guys. T cube's integration, okay, will be t raised to 4 divided by 4. Of course, that 3 is there as it is. The whole thing with 0 and t plus 2 dt. dt's integration is t. So again, 0 and t is there is equal to x minus 1. So this will be nothing but t raised to 4 divided by 12 minus 0 raised to 4 divided by 12 plus 2 into again t minus 0 is equal to x minus 1. So this will become therefore x is equal to, this 1 will go on the other side. You will have t raised to 4 divided by 12 plus 2 into t, and that minus 1 on this side will become plus 1. So this is the value of x. So this is how you can do any kind of question, guys. Cool. Yeah. All right. Cool. Perfect. So those were some questions, and now it's a good time that we solve a question which is coming up on your screen. Okay, let's try to do this. Okay, meanwhile, if you are in ISC board, and I'm guessing Bahut you are in 11th standard, then 100% focus on JEE more, because your 11th standard board exams or 11th standard exams are irrelevant for your JEE or even for qualification purpose. So please focus more on your 11th syllabus of NCERT, so that at least a major chunk is done. Basically, just follow whatever coaching you are in. If you are not a part of coaching, please join one. This is one big mistake which ISC students do. Usually they join a coaching or crash towards the end. So please don't do that. Please start from beginning only. And if you are finding it very difficult to manage time, then I would suggest do those chapters of JEE which are being currently taught in your school or college. Same chapters you do, because eventually all chapters will be done, but that way you will not find the burden of doing some chapter which is not there in your school. But usually it is in 11th, almost first few lectures or first few months will be almost similar. So try to cover up maximum JEE syllabus. Don't keep even single backlog. As soon as you enter 12th, try to finish off your entire syllabus by September, October, and start your JEE preparation for 12th in March or April only. That is the usual thing which many students do, so that they have leisurely or they can complete the portions comfortably, and they have enough time for other activities and pre-boards and other practicals, journals, etc. Okay, so focus on JEE. And let me tell you, the JEE paper, is becoming trickier and trickier. That means we also need to keep our mind sharp and alert. The competition is also good, but let me tell you, there are many people who are lazy, many people who are ignorant, many people who just think that JEE, oh, if I get 80 percentile, it is like 80%. Remember, it is percentile. Even 94 percentile is of no use. It's not like 95% in boards. So we need to be in the top 1 or 2 percentile. Then we can get a seat in NIT and IIT. And I was just getting I just got a message from one of our students, in the morning a few days back. And I was very, very thrilled to see that the student has now started a AI startup and doing extremely well. Did his IIT from IIT Bombay, and I'm super duper proud of that student. So, these are the things which not only makes the teacher proud, but also you yourself become very, very confident. You know that you can achieve so many things because you have cracked the best exam, you have cracked the toughest exam, and there are so many wide opportunities which will line up for you. And just because you are from a top college, automatically so many funds and ideas and collabs and alumni support and innovation hubs, so many things just fall in place right in front of you, so that you can build your startup or do whatever the next big thing you want to do. Okay, so please put in your 100% for the next 1 or 2 years. JEE, JEE, JEE. That should be your focus, nothing else. Correct? Right. Yeah, Anshika, I was just giving you motivation only now, all this while, I guess. If you didn't get motivated by this, I don't know what else to say. All right, so what about this? Magnitude of the velocity of the particle. X is given. So velocity is dx by dt. So it will be derivative of 5t square minus 4t plus 5. So 5 is as it is. T square's derivative is 2t raised to 1. T is derivative is 1. Constant's derivative is 0. So this will be 10t minus 4. 5 2s are 10. So that is in general velocity. So now velocity at 2 seconds, meaning time value, I will put it as 2. So 10 2s are 20 minus 4, which is 16 meters per second. Where is it? Over here. B option is the right answer. Everyone with me on this? Perfect. Right. Okay. Awesome. Awesome. Togo, everyone. Great. Let's move to the next question on your screen. There is a particle whose position is again given C0 and C are constants, then which of the following is correct? Acceleration, acceleration, acceleration. So acceleration means I have to find derivative of velocity, and to find velocity I need the derivative of position. So let's start. Velocity is derivative of position. So d by dt of this whole thing, which is c naught t square minus 2 plus c into t minus 2 whole square. So it will be t square minus 2t plus 4. Sorry, not 2t, minus 4t plus 4. I have expanded the brackets. That's all. So when you take the derivative of this whole thing, let's see what and all you will get. T square's derivative is 2t. Then constant is there. So 0. C naught into 2 is C naught into 2 is 2 C naught. Constant's derivative is 0. Plus C is there. T square's derivative is 2t minus 4c. T's derivative is 1. 4c is a constant, so derivative is 0. So therefore, velocity will be 2 c naught t plus 2 ct minus 4c. Now let's try to figure out acceleration. Acceleration will be derivative of the velocity. So derivative of this means 2 c naught into derivative of time plus 2c into derivative of time minus derivative of 4c with respect to time. Derivative of time with time is 1. So it will be 2c naught plus 2c, because t with t is 1 only. This is a constant, so 0. So it will be 2 common c naught plus c. That is the acceleration. 2 into c naught plus c. I can see option A already matching over here. No need to check anything else. That is the right answer. Correct, option A. Very good evening, everyone. Yeah. Perfecto. Amazingo. Awesome. All right. All right. So the entire of syllabus, guys, you will have to complete, no matter whether you are 11th or 12th. If your exam is in 2027, then you should complete it by October of 2026. If your exam is in 2026, then you should complete it by October of 2025. Okay, ideal time, so that you get enough time for revision. Next one. Velocity time equation of a particle moving in a straight line is given. Find the displacement from the mean position at the time is equal to 1 second. If it is given that at 0 it is 20 meters, and acceleration time equation. Two things are there. Let's do one by one. I think finding acceleration is easier because velocity is given. Acceleration is derivative of velocity. So it is just the derivative of velocity, which is how much? 10 plus 2t plus 3t square. Okay, 10 is a constant, so derivative is 0. Times derivative with respect to time is 1. 3 is a constant, t square's derivative is 2t. So therefore, it will be 2 plus 6t. That is the acceleration. So we found the acceleration time equation. This is done, dusted, sorted. 2 plus 60 in general. Now let's go to the first part. Displacement is asked. So if displacement is asked from velocity, you need to go reverse. You have to do integration. You have to do integration. So be careful. So displacement is asked. So integration of velocity with respect to time is nothing but change in the position from t1 to t2. Okay, integration of velocity. Velocity is that big number. 10 plus, what is it? 2t plus 3t square. So many terms are there. dt will be final minus initial. Initially, you are already at 20 meters. It is already mentioned over here. So when time is 0, you are already at 20. How much is your displacement when the time is 1 second? This is the upper limit. So when the time is 1 second, how much is your displacement? That is how you frame the limits with the final and initial values. Okay. So we just need to integrate this, I believe. So this will be 10 and t, because 10 dt will be integrated as 10t from 0 to 1, plus 2t's integration will be nothing but 2 into t square by 2, again upper limit and lower limit, plus 3t square's integration will be 3t cube by 3, upper limit, lower limit over here, s minus 20. So therefore, what do we get? This will be nothing but 10 multiplied by t minus 0 plus 2 cancels, just t square will be there. So t square means, oops, sorry guys, this was 1, no? My bad. I'll just redo it. So first put 1 over here. So 10, 1 minus 0 plus 2 cancels. First put 1. So it will be 1 square and then put 0. Okay. Plus then put 1 and then put 0. 3 has got cancelled. So 1 cube minus 0 cube is equal to s minus 20. Is equal to s minus 20. So this will be 10 plus 1 plus 1. Yeah. Is equal to s minus 20. So therefore it will be 12 is equal to s minus 20. Therefore displacement is 20 plus 12, which is 32 meters. So that is the answer, 32 meters. Yeah, everyone? Got it, guys? Everybody? 32 meters. That is the answer. Yeah, perfect. 32 meters and 2 plus 60. That's exactly what we got. 32 meters and 2 plus 60. Cool. Let's do the next question on your screen. A particle is going such that x is 1 plus t square. X square is 1 plus t square. Its acceleration at any time is how much? Very interesting question. Very interesting question because x square is there. So you need to be little bit careful about this. Question is acceleration at any time is how much? Okay, let's figure it out, boss. Okay, let's do this. If you take, if you take x square is 1 plus t square, I cannot take the derivative immediately. I mean, I need derivative of x with respect to time, but then you will be like, so take, no, what is the harm? So fine, I can do it like this. X is root of 1 plus t square. So then velocity will be derivative of x with respect to time means derivative of 1 plus t square's root. We can do this derivative. It's not a big deal, but I don't like it doing it that way. I mean, because roots are there, it's a function of a function. I have to use chain rule and all of that. Big headache. I don't want that headache. So I have an idea. See, I have x square is 1 plus t square. Differentiate with respect to time on both sides. Differentiate with respect to time on both sides. See, what do you get? Derivative of x square with respect to time is derivative of 1 plus t square with respect to time. Ideally, I cannot take the derivative, so I have to use chain rule. So I will write it as dx by, or dx square by dx into dx by dt. If you notice, dx and dx gets cancelled. This is nothing but called as the chain rule of derivatives. You form a chain. At the end of the day, when dx cancels, you will get back this relationship. Okay, this 1 is a constant. I can take the derivative. T square's derivative is 2t. You might be wondering, sir, why did you not use chain rule here and how did you not use chain rule here? The answer is simple. When you are differentiating it with the same variable, no need of chain rule. You can directly do it. Directly apply the formulas. Like here, t and t. But here, there is x and t. I cannot differentiate it. I need to convert it with the same variable. If it is x, x. If it is t, t. But still you are like, sir, this is x and t. Will we again apply chain rule? I'm like, no, hold on. Wait a minute. I'll tell you, there is one interesting thing which will happen. Now, x raised to 2's derivative, what will it be, guys? Think logically. X raised to 2's derivative will be 2x. Okay. This dx by dt is exactly velocity. Oh, wow. So dx by dt, I have written it down as velocity. And on the right hand side, it is 2t, 2 cancels. So velocity is 2 by, sorry, not 2 by, t by basically x. Interesting. Or I can also write it as position into velocity is time. Very nice equation I got. Sir, but the question is on acceleration, sir. You have not yet got the answer. Correct. I have not yet got the answer. So let me proceed with the next part of the problem. So if position into velocity is time, let me differentiate on both sides with respect to time. Let's see what do we get. Derivative with respect to time of x into v is the derivative of t with respect to t. These are two things multiplied. It is u into v, product rule of derivatives. So take the first as it is, take the derivative of the second guy, plus take the second function as it is and take the derivative of the first person, dx by dt. This dt by dt is just what? Just leave it as it is. What is dv by dt? Wait a minute, it is acceleration. So this will be x multiplied by acceleration, okay? Plus v as it is. What is dx by dt? Dx by dt is nothing but velocity. Interesting. So therefore, I'm coming close to the answer, by the way. Acceleration into x is equal to 1 minus v square. 1 minus v square. 1 minus v square. But what is v? If you notice from the previous slide, v is nothing but t by x. V is nothing but t by x. So v square will be t square by x square. V square will be nothing but t square by x square. Therefore, acceleration into x is 1 minus t square by x square. Got it? V is t by x. I've just substituted velocity as t by x over here. What next, sir? I'll just go with the flow. I'm just not stopping, guys. Unstoppable Shreyas Sir. Oh, I have over here all these things. I can see x square is 1 plus t square, or t square is 1 minus x square over here. Can you see that? T square is x square minus 1. We can do something over here, or 1 or x. Just take the LCM. X square minus t square by x square, and we can see that t square is x square minus 1. T square is x square minus 1. Can you see that from here? Can you see that from here? T square is nothing but x square minus 1. So that's what I've done over here. T square is x square minus 1. I've substituted it. All right, denominator as it is x square. X square cancels. I am just left with minus minus is plus. So 1 by x square, and this is a into x. Oh, bring it down. So acceleration will be 1 by x cube. I think I got what I wanted. Acceleration is 1 by x cube, means x raised to minus 3. So x is raised to minus n will be 3. Hence 3 should be the answer. Wow, perfecto. I loved the answer. Beautiful, lengthy method, but no other choice. The length of the problem was needed. Okay, it's a good question. You have to do with that. Yeah. Okay. No, it is not 1. It is basically, yeah, 3, not 1 by 3. Okay. Fair enough. See, if you have done any silly mistakes somewhere, there are high chances of a lot of silly mistakes throughout the problem. So be very, very careful. Okay. So I explained it in a beautiful, beautiful manner. Now I can give you some more questions on non-uniform motion. See, sometimes they can also give you something like this. Okay. Like say, for example, v is equal to x square. Can you find acceleration as a function of x? Okay, this is also a very common kind of question. Velocity is given as a function of x, and find acceleration as a function of x. That is asked. Okay, Yeah, if you are a part of the prime batch, then Gokul, the classes would have already started. I mean, today is the first day. In fact, today my lecture was there in the Sigma batch. If you have missed it, then please watch the replay, or maybe you will get the replay from tomorrow. Maybe it takes some time. Okay, because 21st was the joining date. So I'm guessing from tomorrow onwards, you will be able to see all the classes. Okay, cool. So some of you already started posting the answers. Okay, how to track the study materials Jack Lab. See, if you are already a part of the Sigma batch or any prime batch, let me see if it is openable for me. It will be somewhere here. Let's say, for example, some random batch I'm opening. See, you will see here, for example, physics, assignments, classes. All these are the classes. Assignments will be seen over here. Okay, how many assignments you have solved will be seen over here. Other content will have the Tattva books. The Tattva books are over here. Again, if you go back a little bit, you can go to schedule. You will see the upcoming classes. If you want the calendar view, you can see the calendar view every day, what classes are there. Okay. If you want past classes, you can go here. You will be able to see the tests or lectures, whatever you have missed, any notices and performance. How was your attendance, homework, how much you are doing, test attendance, everything. In class, how is your performance? Last week, how was it? Everything you can track over here. Okay. So this is how you can go about it. Cool. Okay. Now let's see how do we do this particular question. Okay. Acceleration usually is a derivative of velocity with time. So if I use that concept, velocity being x square, that is what I will get. Problem is, I can't differentiate x with time. And I just told you variables have to be similar. And if they aren't, use chain rule. So exactly use the chain rule here. So it will be derivative of x square with respect to x is doable. Since you divided by dx, multiply by dx. And do not forget the dt here. Even if you cancel, you will get back the same thing. Now this is doable. X square's derivative is 2x, right, raised to 1. And what is dx by dt? That is itself velocity. To wait a minute, velocity, wasn't it x square? So put it back. So won't acceleration be 2x cube? So we got the answer. Acceleration is 2 times of x cube. Done and dusted. Got it? These are the kind of questions that you might get in non-uniform motion. Means acceleration is not constant. You are no longer allowed to use kinematic equations. You have to stick with slopes, areas, derivatives, and integration. Another cool question can be where, let's say, acceleration is given to be 1 by x. Okay, this is, let's say, a question. And they say velocity is 1 when x is equal to 1. Question is, find velocity as a function of x. That is a kind of cool question which you can get again. Acceleration is 1 by x of a particle. Can you find how will the velocity vary with x if when x is 1, v is also given to be 1? Okay, let's try this out. As I can see, I'm at acceleration, I'm going to velocity, so you have to integrate. Okay, so that one thing is there in my mind. Second thing, remember, from velocity to acceleration, it is always derivative. So, okay, I will most likely need integration. And why have they given this? Most likely for the limits of the integration. So that is also another hint that usually in derivative questions, it's not needed. At this point, this is the thing, not needed. In integration, you need the limit data. That is why it is given. So it's now 100% that we need to do integration. Okay. So how do we do integration? But see guys, integration of acceleration with time I can do. I'll get change in velocity or velocity as a function of time. But there is no time over here. So my usual formulas are no longer applicable. Oh my God. So what to do, sir? Go back. Acceleration is 1 by x. Acceleration is the rate of change of velocity by definition. Now I don't like this. V, t and x, 3 variables and 2 sides, LHS, RHS. No, Not good. Two sides, LHS, RHS, so two variables should be there. So get rid of one. How? By using again chain rule. So differentiate with respect to x. Obviously multiply with x so that the equality is preserved. Now see what happens. I will say dv by dx as it is. But the dx by dt? Dx by dt is the rate of change of position, which is velocity. Oh, wow, sir, this is so cool. This is 1 by x as it is. Now I have two variables, v and x, and two sides, LHS and RHS. Doable, solvable. But don't mix up the variables. On one side, let the variables be of one kind. Monkeys on one side, donkeys on the other side. So velocity on one side, x is on the other side. So therefore, v into dv is equal to dx on the top with x below. Now what do? Integrate. That is the only thing remaining. Okay, integration of v dv is equal to integration of 1 by x dx. Substitute the limits. When x is equal to 1, then the velocity is also 1. When x is x, the velocity is unknown velocity v. When x is 1, v is 1. When x is x, v is v. That's what we need to find, velocity as function of x. V's integration, this is v raised to 1, is v raised to 2 divided by 2. Oh, do not forget the limits, v and 1. What is 1 by x's integration? It is basically log of x, obviously to the base e, and that's it. So put 1 and put x over here. Okay, so this will become v first and then 1 next. Subtract them and put divided by 2 is equal to, put log of x to the base e and then put log of 1 to the base e. All right, what do we get? This will be v square minus 1 divided by 2 is equal to, this is nothing but ln x only you can write, or log of x also is okay. Log of x to the base e. What is log of 1? What is log of 1 to any base? By logarithm formula, it is always going to be 0. Log of 1 is always 0 because e raised to 0 is 1. Anything raised to 0 is 1. So that's why log of 1 is 0. Okay, so what is it that we wanted? So v square minus 1 is 2 log of x to the base e. So therefore v square is equal to 1 plus 2 times log of x to the base e. Therefore v is root of 1 plus 2 times log of x to the base e. Log of x to the base e usually can be written down as ln x. That's the short form of writing it. So v is root of 1 plus 2 ln x. That is the function of velocity as a function of x. Done, dusted. Yeah, we couldn't integrate it first because you cannot integrate variables of different kinds. So I know you guys are thinking probably like this, sir, can't I integrate acceleration with time? Fine. How can I integrate this? Because acceleration is 1 by x. How can I integrate this? This is x, this is time. Not allowed. If this is x, this should be dx. If this is t dt, this should be t. Then it is allowed. This kind of integration, not allowed. That is why we needed all this business of changing the variables so that it becomes integrable. V dv integrable, x dx integrable. Got it? Everyone? Good evening. Is it JEE level? What do you feel? What do you think? This is so difficult that this is Olympiad level? Definitely not. This is a normal JEE question, guys. Don't say, sir, is this JEE level, sir? I thought JEE questions are easy. What are you guys saying? This is normal level only. Yeah? Good evening, Anirudh. And Shreyas Sir, student. Man, please don't tell me that it is not JEE level. Okay. So, in this question, as we saw, we can't integrate acceleration to get velocity because acceleration was 1 by x. This is non-integrable. Non-integrable. I saw the two hints, like some data is given, and from acceleration, I have to go to velocity. So that gives me a hint that I have to use integration, but can't do it in this form. So I wrote acceleration as dv by dt, which is standard formula. But dv by dt, I don't like it. V, t and x, three things, LHS, RHS, not doable. So dv by dt, I just wrote it as dv by dx and dx by dt. Anyways, dx cancels. This is called as the chain rule. You build a link, the link is dx over here. So this is a chain rule. But what is dx by dt? That is velocity. Okay. Now I have vv x dx. Perfect. Done. So take dx on the upper side. So now you put integration on both sides. As per the information, when x is 1, velocity is also 1. When x is x, what is the velocity? It is v. So v raised to 1's integration is v square by 2. 1 by x's integration is log of x. Okay. Substitute v, substitute 1. Substitute x, substitute 1. Simple. So this will become this. But remember, log of 1 is always 0. That is in logarithms. If you have not yet studied it, ignore. And then I just multiplied by 2. And I took 1 on the other side. And this was squared. So I took the square root. But log of x can also be written down as ln x. So that is a shortcut way of writing that the base is natural log. Okay, that's all. Okay. Yeah, the change in the acceleration, yeah, there are different terms, jerk and all that. So there is no end to it, because then what will be the rate of change of acceleration? Let's say I call it as jerk. Then what is the rate of change of jerk called? And what is the rate of change of that called? So it becomes endless. So usually we stop at acceleration, because then you can find out infinite levels of slopes and derivatives. Cool? Clear? Perfect. Let's do some position time graph questions. Let's do some position time graph questions. And before going ahead, let me give you one small shortcut for solving questions, guys. This you will thank me now. Okay, you will thank me now. What is it? You have position, you have velocity, you have acceleration. If you jump from position to velocity, take dx by dt, which is nothing but slope of position versus time. If you go from velocity to acceleration, find the slope of velocity versus time, which means dv by dt. If you go the reverse, acceleration to velocity, integrate acceleration with respect to time, that will give you change in velocity from, let's say, t1 to t2, which is area under acceleration versus time. And if you go from here to here, integrate this velocity from some time to another time, that will give you nothing but change in position, which is displacement. So that is area under velocity versus time. This chart will help you for many questions. And one extra piece of information, sometimes you might also have to write acceleration as dv by dt, which is also dv by dt, which is also dv by dx into dx by dt. So dv by dt was there, but dx if you deliberately write it down, then what will happen? It will just become dv by dx, and this dx by dt, what is dx by dt? That is velocity. So dx by dt is nothing but velocity. So I can just put it over here. So this chain rule is also used in many questions. So if you know this chart in your mind, if you have practiced it using this chart many times, that's it, your job is done. So use this. Cool, everyone? Yeah, you can write acceleration as the second derivative of position, but that's also derivative of velocity, who is itself the derivative of position. So let's do questions of position time graph. I've already given you the theory right over here. Where did it go, man? Yeah, position time graph. Yeah, displacement time graph. We have already seen this. Yeah. So all these graphs I have already given it to you over here. So let's start doing separate questions on them so that you get a complete hang of it. So many questions we have solved. My God, already. Let's do this. The displacement graph is given. The average velocity is asked between 5 and 7, not instantaneous. They have asked average. Let's try and recollect what is the definition of average velocity. What is the definition of average velocity in one dimension motion? Displacement by time, displacement by time, and displacement is change in position. That means final minus initial, and the time also, final time minus initial time. Okay, so what is final and what is initial over here? This is basically your final, this is basically initial. So during this duration, you are trying to find out everything. So the final position is 27.4 minus initial position is 10, whole thing divided by final is 7, initial is, what is it given, 27.4? Okay, anyways, final time is 7, initial time is 5. So 7 minus 5, everyone. So what will this be? 17.4 divided by 2. What is this going to be, guys? Yep, 17.4 divided by 2. Yep, it's going to be 8.7. So which is option number B. Yep, option number B, 8.7 meters per second. That's it. Perfecto. Super duper. Clear. Very good, Gokul. Awesome, Shreyas. Some Abhijit, come on. Everyone. Anirudh. And everyone. Yep. Come on, come on, come on. Togo, Jax, Kiran. Come on. Bhavot, Hansika. Everyone should start answering. Very good, Taruna. Excellent day. Awesome. Let's go to the next question. This is a lengthy question, but we should do it. Read it carefully. Okay, it's a big one. Read it. There is a graph of displacement time, and they are asking you which of the following is correct. This is a JEE advanced type of question because more than one options can be correct. So think carefully. Manu, okay. So let's do this. At least few options, so we can do it directly. I mean, like, look at it. Average velocity from 0 to 9 is 0. 0 to 9. So let me make multiple things over here. Okay. And I think the options are given on the next slide. Okay. BCD, BDE, ADE, BC, etc. Okay. So let's see one by one. 0 to 9, this is 0. This is 9. So if you look at the average velocity from 0 to 9 seconds, final position 0, initial position 0. So displacement is 0. So therefore, average velocity is also going to be 0. So E option is 100% correct. Can you see that? It is very obvious, like you have not changed the position between 0 and 9. Okay. Then maybe another thing, average velocity during 3 to 5. 3 to 5. If you notice this part again, 3 to 5. This is 3, this is 5. Your position is always the same. Okay, slope is 0. So displacement is 0. So again, average velocity is 0. So this is also going to be correct. So B and E options are correct. Between 3 and 5, 0 velocity. Between 0 and 9, average velocity is 0. So B and E are correct. So if you look at the options, B is here, B is here, B is here. Sorry, B is here. And if you see over here, E is over here, E is over here, and E is over here. So at least few options, so I can directly eliminate because E is not present here. This can't be correct. This may be correct, but here B is not there. So C option also gets eliminated. Now, if you notice, looking at the options only, you can figure it out that both of them, sorry, this B and D options between which I am confused, the only deciding factor is either D or C. If D is correct, this is correct. If C is correct, this is correct. So I don't have to waste my energy on other options like A and other things. So either find D or find C. Getting my point? Either do the question for D or do it for C. That's enough. So you decide whichever is easy. Instantaneous velocity you want to find, or you want to find the average velocity. Both also you can find it, guys. It's not that difficult. See, instantaneous velocity at 2 seconds. That means here, that is the slope. So that means you need to find this particular thing. If this is theta, if that is theta, sorry, tan of theta. So instantaneous velocity is nothing but the slope, which is nothing but tan theta, which is nothing but height by the base of the triangle. Height of the triangle is 5. Base of the triangle, what is this? 2 to 3. It is 1. So that's it. It is 5 meters per second. So instantaneous velocity at 2 is 5 meters per second. So C is obviously correct. So naturally D will be wrong. But even if you try to find it, I mean, you can get the answer why it is wrong. The average velocity from 5 to 7. Average velocity from 5 to 7. Check this out. The average velocity from 5 to 7. Time interval between 5 and 7 is 2 seconds. So final minus initial, which is 2. And position wise, final is 0, initial is 5. So 0 minus 5, which is minus 5 by 2, which is minus 2.5 meters per second. And it says is 6.5, which is 100% wrong. So D is wrong, C is correct. So naturally, D if it is wrong and C is correct. So option D should be the right answer. Got it? How we narrowed it down? You don't have to sit and solve everything. Just look at the options and you can start eliminating it. Yeah? Cool? Yes, C was true. Perfect, 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 my dear warriors. So this is how the questions are. So moving on to another question. The displacement graph of two particles making 30 degrees and 45 degrees is shown. The ratio of their velocity is. Guys, displacement time is given. So the slope of displacement and time graph gives you velocity. And the slope, what do I mean by it? It is the tan of the angle made by the tangent. Already it is a straight line. The tangent is the line itself. So the velocity in the first case upon velocity in the second case will be tan of the first angle by tan of the second angle. Tan 30 is 1 by root 3. Tan 45 is 1. So it is 1 by root 3. So that's it. That is the answer, 1 by root 3. Very straightforward. The tangent for the straight line is the straight line itself. So the angle made by the tangent, you find the tan of it. That is the slope, which is the velocity. That's it. Direct question. Okay. Fair enough. Let's do now some questions on velocity time graph already given to you. What does the slope of velocity time give you? Slope of the velocity time, rate of change of velocity, acceleration. What does area of velocity time give you? Area of velocity, area integration of velocity, displacement. Yes. So area gives you displacement, slope gives you acceleration. Okay. Right. Let's see. The velocity graph of a particle is as shown. The distance traveled in the first 4 seconds is, okay, the velocity graph is given, distance displacement means area. So the area under velocity versus time gives you that displacement. So as you can see over here, we just need to figure out the area between 0 and 4. So it will be half, it's a triangle, right? Half into base multiplied by the height. What's the base like? It's 4 units. What is the height like? It is 8. 8 by 2, 4, 4, 4 is 16. So 16 meters is the displacement, which is B option. Perfect. That's correct. So area under velocity time gives me the displacement. In this case, the displacement and the distances are equal because it is going in one direction only. It is not reversing. If it reverses, then it would have been much more trickier. Okay. By the way, remember, by chance, if the graph goes below, right? let's say this is a graph, it is going like this. This is positive, this is negative area. So if you see that this triangle was below, then this area will be negative 16 meters. So be careful. Okay, that negative means the direction is opposite. You are not going in the positive direction, but you are reverse the direction. So be very careful. Those areas may have sign if it is below the horizontal axis. Right now we were safe. How about this question? Which graph corresponds to object moving with constant negative acceleration and positive velocity? Velocity time. Okay, positive velocity means what? Positive slope of acceleration versus time. As you can see over here, if I draw a tangent to the curve here and here and here, this is velocity distance, so be careful, don't touch it right now. This is negative uh, positive velocity. Sorry. Positive. What did I even do? Sorry, guys. Constant negative acceleration is asked. This is what I should have concentrated on. Constant negative acceleration means negative slope of velocity versus time. Acceleration is rate of change of velocity. So negative acceleration means negative rate of velocity. So velocity graph has a negative slope. So if you see velocity graph has a negative slope, here it has positive slope, negative slope and positive slope. Here it has definitely only positive slope. So this option number B obviously gets ruled out because it says it should be constantly negative. It can't be positive. Even A option gets ruled out because how did negative become positive? It should always be negative. It should always be negative. So it can't be A, it can't be B. Is this absolutely clear? Everybody with me till this point? Okay, sir. So it can't be A and B, sir. Okay, what about this positive velocity? That means velocity itself is a positive value. In C and D option, velocity, you can see it has positive values. Velocity, it has positive values. So C can be also correct, D can be also correct because here also it is positive, positive, positive. Velocity is positive, 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 positive. Remember, this is 0, this is 0. So everywhere, no matter where you go, here also, or here also, or here, or here, the velocity is always positive. So it can be D also or C also. I need to figure it out. I'm not yet sure about it. Okay, how do I make sure? There is one thing given to me, constant acceleration. That word itself gave everything out. Constant acceleration means kinematic equations are allowed. I can use kinematic equations and I can see velocity and x over here. So therefore, v square is u square 2ax, but acceleration is negative, that means minus. Acceleration is negative, that means some negative. It is clearly mentioned, it is negative acceleration. Minus 2x, your third kinematic equation. Guys, this is a quadratic equation. Quadratic equation. And if you look at it carefully, this is your y-axis, this is your x-axis. If y is x square, then the graph is like this or like this. But when y square is x, then the graph is like this or it is like this. It's a parabola with the x-axis as the axis of symmetry. Okay, so be careful over here, since I will give that theory if you want on the next slide. If y was proportional to x square, then the parabola can be like this or like this, depending on whether it is positive coefficient or negative coefficient. But when y square is proportional to x, then the graphs are either like this, that means the parabola is like this, or it is like this. Okay, one of them. So here, this is the scenario. So we need to go back. So as you can see, this is definitely not a parabola. It is like an asymptote. So D option automatically will get ruled out. D option automatically gets ruled out. Can you see it's an asymptote over here? It's not really intersecting. This is a hyperbola like figure. Here, I think if you continue this, I mean, it is not really drawn. This becomes a parabola, which kind of makes sense. So it's a parabola with negative coefficient of x 100%. It will be like this. If it was positive coefficient of x, it would have looked faced towards your right hand side. The cup, the C would have faced right side. The C is facing opposite way because of that negative value. That's all. Okay, rest all is fine. This u square has come only because of some distance over here. So there is the parabola is not passing through the origin because of this constant term which is there. So that's why the parabola has shifted by some amount. Cool. That is the logic behind it. Yeah. Sir, is it normal in 9 to feel the tricky questions a bit difficult? Abhijit, forget normal questions. Forget tricky questions. It's quite normal for a 9th standard student to feel even the normal questions tricky. Do you ask tricky questions difficult? No, tricky questions will be very difficult right now for you, but even the normal questions will look difficult. It's natural. And this is exactly the process you should go through. I have complete faith that if you are 9th, 10th standard students who are watching these classes, by the time you reach 11th, these problems you will solve very easily, and you will be looking forward for more good level questions and very, I mean, Olympiad type questions, J advanced PYQs, and this and that mixture questions, and you will try to solve many other books. So it's a good path. You are on that momentum, on that track. Don't stop. Okay, just continue. Right? Shreyas Sir, teaching maths is the moment of the day. Oh my God, what should I say, man? Physics is half of it is maths only. See, not just in pro, but even in prime, the moment you start performing well in the test, we will automatically, move you to the higher batches, move you to the, batches where, we will make sure that you are solving more difficult questions. It's true throughout Vedantu. Okay. So that is why I keep telling, please solve the test paper seriously, take the assignment seriously. See, we get the performance reports, like this. I just showed it to you over. It's not just for you, but even for us, we get the performance of a student and we keep a track of every student who is a part of our batch. Okay. So we have academic mentors, like how many classes are you attending? What's the test percentage? What is your attempt marks? What is your accuracy? And what is your homework completion rate in class? How are you doing? So if all of this looks good, right? That's when we put in that extra effort by giving more questions and higher level order of questions. And we will definitely train you, okay, with the Eklavya modules then. HCV daily is like eating an apple every day, which is very good. Okay, moving on now to the next question, but this is a homework question. Just take a screenshot of it. I want everybody to post the answers in the comment section after the video ends. Okay, just take a screenshot. Fantabulous edits, it's up to you. Moria or JEE Sigma, it's completely up to you. JEE Sigma batch is the English batch. Moria is a Marathi mix batch, Marathi Hindi batch. Okay, it is not an English batch. So language is different, and that is something which you need to keep in mind. Okay. So charges 1%. Is it right to see live with charging the phone? Yeah, it's fine. Not an issue, Shreyas. All right. Cool. Do this question later on. Let's do acceleration time graph questions. Okay. What does the area under acceleration time give you? It gives you change in velocity, not velocity, change in velocity, area under acceleration time. Remember, integration of acceleration gives me change in velocity. So area under acceleration gives me change in velocity. What does the slope of acceleration time give you? Velocity, sir? No. Displacement, sir? No. What else? It is rate of change of acceleration. So it is not a term which you might have studied now. So you can call it whatever you want. Okay. But the point is, it is just a rate of change of acceleration. Okay. We do not define it in our JEE physics as of now. Yeah. So be careful. Let's do some questions. And here it comes on your screen. For this acceleration time graph shown in the diagram, the change in velocity of the particle from 0 to 6 seconds. Be careful. 0 to 6 seconds change in velocity is area under acceleration versus the time graph. Now comes the tricky part. See, if you consider this particular area, it's on the upper side, which is going to be obviously positive. But if you consider this area, well, it's below, so it should be negative. So let's be mindful of that. Triangle's area is half, base is 4, height is also 4, 16 by 2 is 8. This half, base is 2 units, height is also 4 units. 2 cancel, so it will become minus 4. So technically, this will be minus 4 over here. And over here, what is that? Plus 8 over here. So 8 minus 4 is 4. So 4 meters per second is the change in velocity, which is option B, of course. Lot of students have seen, they forget taking the minus sign. So they get the area as 8 and they get the area as 4 and they add 8 and 4. 8 and 4 will give you 12. They mark C, that will give you minus 1 marks. So be careful. Okay, Sainivas, I do remember you. Hello, welcome. Okay, perfect. Awesomeness. Let's go to the next question on your screen. Here it comes. The acceleration graph of a particle moving along the x-axis is shown. The particle starts with 3 at 0. Find the velocity at t is equal to 4. Okay, find the velocity at 4 and 0 time what is the velocity is given. The area under this obviously gives me change in velocity. So let's just figure out the area under this graph. Now, how do you figure out the area? That's another question. I have an idea over here. See, think about it. From 0 to 8, and this is 0 to 8, this is an isosceles triangle, right angle. So, if this is 4, how much will this be? This will be 4. Symmetry should be there, isosceles triangle. Okay. Now, out of that area, if you just ask me how much is the area of the rectangle over here, the area of the rectangle over here, that will be breadth into length. So 4 into 4, which is 16. How much is the area of the triangle over here, which is half into the base into the height, that is 8 over here. So the change in velocity, which is the area total, will be 8 plus 16, which is 24. Change in velocity is final minus initial. Velocity at 4 minus velocity at 0. Velocity at 4 seconds, I don't know. Initial velocity, it starts with 3 meters per second. That means V0 is 3 meters per second. So V0 is 3. So therefore, that velocity will be 27 meters per second. That is the correct answer. Yeah, perfect. Thank you so much, Sai. Means a lot. Yes, J say K Krishna Reddy. Whatever doubt you have, please put it up in the chat box. Okay, cool. Let's go then to another kind of thing, which is about graph conversion. This theory you should know because sometimes they give you velocity graph, acceleration graph, and they ask you what is the position graph looking like, or they give you position, what is velocity graph like. They give you position, they ask you what is the acceleration going to look like. So you should know how each graph might look like. and you have to usually analyze it part by part. Sir, is rectangle with 4 by 4? Yes, yes. In the previous question, there was a rectangle with 4 by 4, no? Yeah, what was this side? This side length was 4 units, and this side length was also 4 units. This is also 4 units. Cool? Because 4 units here, 4 units here. And why was this 4? Because of an isosceles triangle, right angle. This is 8, this is 8. So if this is 4, this should be also 4. By simple geometry, we can get it. Okay. Now observe this carefully, guys. See, here different varieties I am putting, of position, velocity, and acceleration. Look at this first graph. If you draw a tangent over here, that tangent goes down, then the tangent becomes 0, then the tangent goes up. This is position time. So the tangent for position gives me velocity. Remember, the slope of the position time gives me velocity. So can you see, because it is going down, it is earlier negative, then because it went like this, then it became 0, and then when it starts going up, then it became positive. So the velocity was negative, then 0, then positive. Look at this graph. The velocity was earlier negative in value, then it became 0, and then it started getting positive values. So exactly what was expected after conversion. And why would it be a straight line? It will be only a straight line if this graph is a parabola. If this is a parabola only. Why, sir, only a parabola? Because parabola means square term will be there. So if you take the derivative of the square term, what will it be? It will be a linear term. So a quadratic equation will become linear equation when you take the derivative. So that is the reason why the velocity will be a straight line graph only if the curve is a parabola. If it is biquadratic, cubic, or some sin x cos x graph, logarithmic graph, e raised to x graph, it will not be a straight line. Does that ring a bell? Does that make sense to all of you? Okay. All right. Yeah, we can use area of a trapezium also. Not an issue. You can use trapezium or divide it into triangle and rectangle also. Now, if you notice this over here, the slope is a constant. The slope is constant. And what does the slope of velocity give? It gives you acceleration. So that is why the acceleration is a constant value and it is upwards. So that's why it is positive constant. That's why you will see the acceleration value is positively constant. Can you see that? Everyone with me? Understood? Now look at this graph. This is also a parabola, but it is inverted parabola. It is an inverted parabola. So because of that, what will happen? Initially, your graph was going up. So there will be a positive slope if you draw a tangent. Then if you draw a tangent over here, it will be 0 slope. And if you draw a tangent here, it is going down, so negative. So the slope over here gives me velocity. As you can see, the slope is initially having some positive value, then it becomes 0, and as you go ahead, it becomes negative. Positive, 0, negative. Because it is parabola, that means it is having square term. So if you differentiate it, you will get a linear term. That is why the graph is a straight line. That is why the graph is a straight line. And once I know the graph is straight line, so we can clearly see that the slope is constant, but negative constant. That is why you will see the graph of acceleration is below the horizontal axis. It is negative, but it is a constant. It is not above, it is below the horizontal line. Is this conversion absolutely clear? You can go reverse also. If this is given, this will be true. If this is true, this will be true. If this is given, this will be true, and then this will be also true. Yeah. The session PDF will be attached in the description box as well as in the comment section. Okay, it will be pinned over there. You can download it by tomorrow. Same way, you can do other conversions also. It's not that difficult. Look at this. The graph is going up like this beautifully. Yeah, this is also upward parabola. This is downward parabola, just like this. Only consider this part, upward parabola. Only consider this part, which is downward parabola. Downward parabola, upward parabola. Same thing, velocity is positive, velocity is negative. Acceleration is positive, acceleration is negative. So you can just take a specific part and how it will look like. Okay, so I have kept a homework question for all of you, right? So this velocity is going up, constant going up and coming down to zero. How will the displacement graph look like? Displacement graph, you have to draw it and figure it out. The solution is there on the next slide. PDF will be having that solution. You can download it and verify your homework answer. Okay, this is your this is your second homework question. Hello sir, please clear your doubt. Sir, I have confusion in where to apply which formula, as in which chapter, like every chapter or this specific chapter. If it is a specific chapter, then tell me which specific chapter. If it is in general, then if it is a generic question, then let me tell you, if you are confused like that, then you are not spending enough time on watching the lecture carefully. Please do that. Don't watch one shots. Please watch detailed classes, not just YouTube, but anywhere. Second thing, please solve the questions which are done in the classroom again at home. Redo the same thing. Number three, solve very laddu easy peasy questions which are direct substitution based. And then when you solve those questions, try it out that formula in different ways. If this was asked, then make that as given and then find what was asked. Okay, try changing the different values and see how the formula changes. Try putting special values. Try changing the question and the values given there. So that's how you build the sense of the formula. Okay, that will help you not just remember, but also help you understand when to use that formula. So try it out for a couple of days and every day make it a point to practice at least 20 to 30 questions of physics. Yeah, irrespective of how many questions of chemistry, maths you solve, bare minimum 20 to 30 questions you should solve. I'm not saying JEE advanced level, just solve JEE mains level, not necessarily PYQs, even the textbook questions, class questions, at least 20, 30 questions, start with it. Okay. And regarding this chapter, I would say you should be very well versed with derivatives and integration, and kinematics you should be able to differentiate from calculus questions. Wherever acceleration is constant, kinematics is okay. If it is not constant, then today's lecture. And for that, derivative and integration should be clear. And it usually is the derivative integration part which takes time. And by the time you reach 12th, you will have a good idea of integration and derivatives. So that's when you will be conversant with those formulas. See, you should also understand that the maths part, which is the formula of derivative, is a different story altogether. But using that formula, what is that derivative, why that integration, why that area, that is the part which you should know for now. So if you're not able to remember all the derivatives and all the integrations, that's secondary. Don't worry about it so much. You will eventually learn it when you reach 12th standard. At least know the few basic formulas. Just learn what is integration, what is derivatives. I have conducted a beautiful class. Watch it on YouTube, or even you can check out my VBuddy classes. Okay, right? Yeah. So after this, we'll start off with motion in 2 dimension. Okay. See you. Bye bye. Have a great time. And I've put up the solution also on the next slide. And make sure you're liking this video, comment this video, and subscribe to the channel. Don't forget. Okay. Bye bye. Take care. Have a great time.